Okay, so this P3 video is on the difference between contamination and irradiation. So what is irradiation, first of all, we're going to look at? Well, radioactive substances are dangerous because they give off ionizing radiation. In particular, gamma rays is the one you need to know about for the core science. And a very common mistake that happens when people are describing the difference between these two things is they get mixed up between the radioactive substance and the radiation itself. So I'm going to try and make it really clear to you what you should be saying about each one. So we're going to start with the radioactive substance and a person standing next to it. And what happens in irradiation is that the radiation from the radioactive substance strikes the person and is absorbed. And of course there is some other radiation that's coming off there, and it comes off in every direction, so some of the radiation doesn't strike the person. Okay? So Bob's being irradiated here because the ionizing radiation from the radioactive substance is hitting him. And what you need to think about in terms of risk is the idea that that can break chemical bonds inside his cells, in particular in DNA, and that could lead to mutation in the DNA, and that could increase his risk of cancer. So we're not saying here that the radiation causes cancer, we are saying that it gives you an increased risk the higher dose you have, basically. Okay. Before we look at contamination, what we're going to do is look at the ways in which we can reduce the risk of irradiation, and that's going to link very closely to why contamination is often regarded as being more hazardous than being irradiated. So first things first, if we move the person away from the radioactive substance, then they're going to get a lower dose. Okay, this is related to the idea of the intensity video in P2, where we saw that the photons spread out the further away from the source they were. These are basically photons of gamma radiation, and the further away the person is, the fewer photons will hit the person. So that's going to reduce their dose and therefore reduce their risk. Okay. Second thing we can do is we can put something in the way. So we can put a material between the radioactive substance and the person that will act as a shield, and what that's going to do is absorb some of the radiation. And again, with gamma radiation, you can never completely absorb it, but if you have a thicker and thicker shield, then more and more of it will be absorbed, and the dose will get lower and lower, and so the risk will get lower and lower. Okay? And the final thing we can do is to make sure that we reduce the exposure time. So if you're working with radioactive materials, you want to do it for as short a time as possible. Okay? So, those are the three things we can do. Increase the distance using something like tongs if you're handling a radioactive substance, or possibly even remote controlling it with a robot. Okay, shield yourself. So examples of that are the concrete shielding around the nuclear reactor, or lead aprons worn by technicians giving X-rays if they have to be in the same room, and reducing the time. That's just a general thing that you can do to reduce the amount of radiation you're exposed to. So that's irradiation. So what is contamination? Well, the key difference with contamination is that where the radioactive substance is. So if you're talking about the difference, you need to say in irradiation, the radioactive substance is not on the person or in the person, but the radiation from it is still hitting them. In the case of contamination, it's when some of the radioactive substance gets on the person or inside the person. So that could be spilled on their skin. If it was in the form of a gas, it could be breathed in. So, for example, radon gas, which can be in the air, can be breathed in, and that might then contaminate the person. Okay. So, obviously, this radioactive substance is still giving off its radiation in all directions. And this time, of course, all of the radiation pretty much, especially if it's inside the person, is hitting the person. It may be that the amount of substance that they are contaminated with is much less than the amount of substance that was being irradiated there. So if it's a tiny drop of a substance, that's obviously a lot less. But the fact that such a large proportion of the radiation from it is then hitting the person increases the risk. Okay? So if you think about it in terms of the factors, the radioactive substance is now so close to the person that they get a much larger dose. They will be exposed for a long period of time, unless they are decontaminated. So that would be, for example, to wash the radioactive substance off the surface of the skin. A lot harder to decontaminate someone if they've had radioactive substance inside them, either through eating or breathing in. And a final thing, of course, is you can't shield the person from this because the radioactive substance is so close to them that you can't get a shield in between the substance and them, the best thing you can do is decontaminate them. So generally speaking then, we think that the risk from contamination is higher than a risk of irradiation, because really, because the substance is on you or in you, you are constantly being irradiated at a high level because it's so close and for a long period of time. So that's the key differences between contamination and irradiation. Make sure you get them all down if you get asked a question about that.